Yeah. So it's no, I mean, all you're doing is finding the derivatives. In this case, it's derivative of y with respect to theta. How do we find the derivative of ln of sine theta? Function of a function, so 1 over sine theta followed by
I thought it was 1.
1
Times cosine.
times cosine.
So is it cotangent?
Yes, exactly.
Is that just the answer?
So this would simply be cotangent theta. So dy over d theta is cotangent theta, which would simply mean dy is cotangent of theta times d theta. That is the differential in y. That is the differential in this is closely related to integrals. I believe I mentioned it last time. You will probably see this come up quite often in calculus too. Are we clear?
Yeah, I thought what you were asking us at the very least to do is what we were doing last class. My apologies. Because I saw the A there.
That's exactly what we're doing, what we did last class.
Last class, the very least we were using what we were doing with approximation.
So we want to find dy over dx. First, to find the differential in y. So we have to use quotient rule. U e raised x, which would mean u prime is also e raised x. V 1 minus e raised x. V prime is negative e raised x. Derivative of 1 is 0. 0 minus e raised x minus e raised x. Good? No. V u prime minus u v prime divided by v squared. So 1 minus e raised x times e raised x minus e raised x times minus e raised x divided by 1 minus e raised x squared.
And so what you end up with.
Distribute the e raised x. You could either do it that way or recognize that this term and that term has an e raised x in common. Yes. If you pull that out, you would have 1 minus e raised x minus times minus plus e raised x.
Which would just leave you with e raised x over 1 minus e raised x squared.
That is correct. So this term and that term will get cancelled. So e raised x times 1 is e raised x divided by 1 minus e raised x squared. Now,
Be better.
dy over dx is e raised x divided by 1 minus e raised x squared. So if we want to find the differential in y, dy would simply be equal to e raised x divided by 1 minus e raised x squared times dx.
Yeah. Or you could even write it as e raised x times dx over 1 minus e raised x squared.
We can, but we want to show that we're multiplying that derivative with the differential.
I was just saying it.
Yeah.
Could you find it with the dy on the other side? Like, let's say you want to find it with the differential of x, would you just do it to where like dy is on the other side?
Yeah,
Would you ever like, what?
but why would we want to find the differential in x? Because y depends on x, right?
So we don't want Y to be on the other side, and just make more problems?
Unless if x depended on y. So what we're trying to say is the differential of the dependent variable is dependent on the differential of the independent variable. Which is why in the last problem, it was dy d theta, because y depended on theta. So the way to look at it is the differential in the dependent variable related to the differential in the independent variable, always. So the book wants to either use linearization or differentials.
Oh,
I'm going to show you that both of them are options to do an approximation. Last time we did linearization. This time we're going to do differentials in addition to linearization. So we have this computation that we've got to do. We can't find the third root of 1001 using your calculator with 10 point something. 10.0.
You're doing it in the calculator?
I think it's 10.3.
Are you solving it right now?
Yeah, I want to know what this is.
10.0033.
0.03, okay. Okay, so, and the 3 is repeating. The 3 is repeating.
And why exactly does it list it as 33322 instead of just 33333?
Okay, it's fine. That's good enough.
Oh.
So it happens to be 10.003, the exact value. We want to approximate this. So what does the linearization state? The linearization of a function is f prime of x times x minus a.
Wasn't it f prime of a?
Sorry. Multiplied by
F of a?
f of what?
No, f of a, I'm sorry. Ugh,
10.0.
I got it.
So that is the linearization of the function f of x. And the entire concept is we pick an x and we go slightly to the right or to the left in the neighborhood of that a to come up with an approximation. Now, what function should you pick if you want to compute the cube root of 1001? What function should you pick?
Different.
You don't know? Suppose I want to find the cube root of 1001. What function is reasonable to use? In other words, you can plug in that
X to the third power,
x to the third
X
power,
cubed,
X to the 1/3.
x raised 1/3, the cube root of x. Right? If it's the cube root of x, using that function, you can pretty much find the cube root of all values. So I'm going to start by saying that f of x equals cube root of x is the reasonable function to use.
that's what I meant.
Good?
So what you end up having, at the very least, is X thirds.
So x raised 1/3.
Yes.
Chain rule.
What would f prime of x be?
1/3 x negative 2
Times x.
1/3 x raised negative 2/3. Correct?
times.
Now, we need to find f prime of A and f of A. Now, A has to be in the neighborhood of which number? Or X has to be in the neighborhood of which number?
1001.
Huh?
1001.
1001, so what is a reasonable value for that? X and A. Last time I drew a picture, right? You can look at the picture. Something like that. I picked an X. And then A. A was very close to X, correct? A has to be in the neighborhood of X.
Correct.
Yes, so in my last case, I picked a value of A, and then I said in the neighborhood of that value, I can pick an X, correct? Yes, that's what we did last time, which is why I asked, did I have it backwards? Depending on that, your formula will change. So the purpose here in using the third root of X is that finding third root of 1000 is easier than finding the third root of 1001. Yes, because 1000 is a perfect cube. So if I pick a number for X or A, what should that number be? Last time I said X has to be in the neighborhood of whatever A I pick, right? So what number would you pick so that you can find 1001?
You would choose either 1001.01 or 1001 minus 0.01, which would be 1000.09.
1000.
Jay, what did you say?
1000.
You picked 1000.
You said some
And the neighborhood is like 1.
Well, no, because last time you said only 2.01.
So
Well, I think we need these whole numbers, not.
exactly, because it'll defeat the point of us approximating the third root of 1001 using the third root of 1000.997.
You said to use 0.01.
So going back here, we're going to use 1000. And let's plug in 1000 in the derivative and the original function.
So do we plug it out?
So 1/3 multiplied by 1000 raised negative 2/3. Yes? Which I can write it as 1/3 10 cubed raised negative 2/3. With me so far. And that would equal to 1/3 10 cubed raised negative 2/3. Those two would go away.
So you get 0.0208, which would just be 0.02.
This would be 1/100. 1/100 is 0.01. You take the divide by 3, you'd have 0.00333. Good. So that's f prime of A. What is f of A? Since we picked an easier number, easier function, A is 1000. So if I plug in 1000 in there, we know the third root of 1000 is 10. Good. So we have found f prime of 1000, f of 1,000, and we got those two values. So the linearization would now become L of x is approximately equal to 0.003 times 1 minus, oops, my brain's going one step ahead, x minus 1,000 plus f of 1,000, which is 10. Good.
So that ends up happening is that you have.
So that is the linearization of that function. The reason I picked that function is because you need a cube root function to evaluate a cube root. You need a square root function to evaluate a square root. You need a logarithmic function to evaluate a logarithm. Yes?
Yeah.
Yes?
Yeah.
You need pecans to make a pecan pie.
Alright.
So f of a is going to then equal.
Question, Enzo?
Yeah, so your answer would vary, it could be different if you use 1,002, for example.
You can, then you have a different line.
Oh, okay, so there's multiple answers.
Yes, now the issue with picking 1,002, if it's 1,002 that you're picking, then this would become 1,002 raised to over 3. Do you know the third root of 1,002 right away?
Yes.
No. Do you? What is it, John? What is the third root of 1,002?
My calculator.
You would use the calculator.
That's a big number.
If you're going to use a calculator here, you could use the calculator there. Why should you approximate? So the purpose is to approximate using something simpler, right? So 1,000, if you choose 1,000, the third root of 1,000 is easy. It'll be 10. If it's a square root function, I would simply pick square root of 100 would be 10. So we're going for easier functions. Don't we?
So wait, so we're going for easier functions because you don't want us to use the calculator, you want us to kind of like, I don't want to say guess, but.
I mean, I'm not going to use the calculator at all, so be patient. So I've got this step, right?
Yeah.
I picked a function that is convenient, or, because it's cube root function. I can easily evaluate the cube root of 1,000 without even using a calculator. And I got the linearization. Yes?
Yeah.
I want to evaluate this approximation at what point to answer that question. 1001. So if I plug in 1001 in there, .003, yes, multiplied by 1001 minus 1,000 plus 10, correct?
Yeah.
1 times 0.003 plus 10.
Are you serious?
I get 10.003.
Oh my goodness.
Yes, I didn't even use the calculator. All I had to do is to pick a function that would be close to what we're trying to find and use that function, find the derivative, evaluate it in the neighborhood, and you got the exact same answer. Yes. So which is why I said it would be a moot point to pick a number that is weird, such as 1,000.9.
I'm just saying, you said also.
Okay, but you did an example like that yesterday, where you used decimal. To use decimals in like the last time we were here,
I just didn't.
with like the -2.1, -2.05.
Because you said-
I see where I'm just thinking about that time.
I understand that.
Go ahead, Jay.
Two questions, so using the differential would do the same thing?
Patience, that's part B.
And second, before you raise it, how did you do S, the prime of A? That whole little, like, the 1/3, 10,000?
I plugged in A equals 1,000.
Yeah, but like, the whole little work you did, like, you put like 10, oh, you know what, I got it now.
Okay.
Existence.
Oh, wait. That is our standard formula. You will quickly see that this and linearization are pretty much the same. F prime of X, we know what it is, we had it already, correct? It was 1/3 X raised negative 2/3. Correct? Multiplied by dx. Yes, no, maybe. And I'm saying that would be equal to dy. So, what point on my function f of x is simply the third root of x, whatever x it might be. Now, I started at a point, I moved slightly to the right over here to end up getting or to find the approximation of 1001. Agree? So if this point is x, it's very close to a, that is my assumption, and a is 1,000, what is the change in y? How would you write it?
X minus F of A.
F of x minus f of a. Call that 1,000 because a is 1,000. And multiplied by dx. And what would that give me?
What you would end up with is basically,
What would a and x be? The change in from a to x? 1. That would simply be 1. If I move this negative f of 1,000 to the other side, I would simply get f of 1,000. Correct? We know what f of 1,000 is. Correct?
f of x is going to be equal to f prime of x.
And here we want to look at, what amount did you move from A to get to 1,001? In other words, that differential that I found is applicable at that value, A. So if I evaluate, let's see, at 1,000, what would I get if I plug in 1,000?
You get to.
What would you get? 10.
What?
This is 10. Right? So I should have called it using a different name. Let's say it's.
Aren't we talking about?
I overcomplicated what I'm supposed to do. So going back to the differential in y, differential simply means the change in y. Correct? You change from some number by a tiny amount. So that differential in y is simply 1/3 From 1,000, you move by a tiny amount, correct? So 1,000 raised -2/3. And what is that tiny amount that you move on the x-axis? That the x, it's 1. So 1/3 raised same argument like the previous one and raised -2. Which would give me 0.0033. Yes? So what the differential states is if I change x by that 1 unit, the value of y is going to change by that amount. So what is the value of y at 1,000? Times x minus 30 degrees plus f of 30 degrees square root of 3/2. Yes. Now we all plugged in 29 degrees, life was great. We ended up getting -1 degrees, life was great. We multiplied that by -0.5, things were great. We got 0.5 degree, was great. We added 0.866 to 1/2 degrees. And what happened?
We were wrong.
We were wrong because 1/2 plus 0.866 will be,
366.
huh?
1.36.
It will be 1.366 because 0.5 plus 0.866. But what we fail to realize is you cannot simply add a degree to a number. So how do you convert degrees to radians?
180, I don't know which one it is. Is it 180 over pi or pi over 180?
Pi over 180. Multiply this by pi over 180. What do you get? Pi over 360 degrees. Oh, which is the degrees will get cancelled, right? So 1/2 degree. No, easier way to remember. 360 degrees in the denominator. Degree will get cancelled. So you get it.
Okay, gotcha.
So that would be pi over 720. Yes. Oh, sorry. I wanted to demonstrate something today.
I thought it was 180.
I was 180.
You can do either.
180.
Yeah.
It'd be 2.5.
Oh, yeah.
Well, then you're.
But that's the AC.
No. 1/2 degrees multiplied by pi over 180
Oh, equal.
is pi over 360.
Oh.
Pi is 3.14.
Yeah.
Okay.
It's actually 3.141592653.
It's like those bobbleheads from that museum.
I'm sure.
Bobbleheads from that museum.
And what do we get? 3.14 divided by 360. How much?
1.8747.
0.8747. What is the value of cosine 29 degrees if you put it directly in the calculator?
Is it that argument? 0.875.
0.875 exactly.
Well, it was around.
It's 0.8746. So,
Oh, 8746, 0.4 decimals. So the actual value using the calculator is 0.8746. The value using the linearization is 0.8747. Is it close?
Yeah.
Really close. What the mistake that Caitlin made, Helga, pretty much everyone did
I didn't get that.
is not converting
Probably like that.
degrees here, right? Hayden, you got the help now?
Yes, thank you.
So you have to convert degrees to radians before, or else you'll get wrong answers.
So my question is, how come when we swapped out X and A, right, that you got the right answer?
You'll still get, because the negatives will get cancelled. Remember in slope, you can switch x1, x2.
We got time.
If you switch x1, x2, y2, y1 equals the switch negative over negative.